As promised that we will continue 6.2 on the next video. Due to time, I'm only limited to doing videos that are of 30 minutes. So all right, now we are continuing where we left off. We say 1 minus, we were about to manipulate this. What is 1 plus 0,0525 divided by 4? We get how much there? We get 161. Let me check. 1621 divided by 1600 to the power of negative 4n. Then now what will happen is that if I were to remove this, do you see what's happening here? So I can take this to the other side, right? So that it can be 1621 divided by 1600 to the power of negative 4n. It is equal to 1 minus 17, 1 minus 7 divided by 16 rather. 1 minus 7 divided by 16. I get a value of 9 divided by 16. Therefore now we now know laws of logarithm, right? So if I want this is going to be negative 4n, it is equal to, I drop it illegally by introducing log of what? Of the base. What is the base? This is the base. 1621 divided by 1600 to the power of what? This part. Then this is just a matter of you punching that in your calculator. When you punch that in your calculator, you get 9 divided by 16. You get negative number, right? So that negative number that you get, say divide by negative 4 thereof, then you get what? You get n as 11,03. Okay, then they said what? How long in years? So you're gonna say 11,03 what? 11,03 years. So that's all. Actually, today's video was supposed to be this part, counting principle now. So let's move on to question 7, the actual topic of the video. Now question 7, now in this case it is a derivative rules as well as counting principle. No, as well as first principle. So now 7.1 says determine f prime x from the first principle. So now that you know the rules, you can say my expected answer is supposed to be negative 4x only. This is my expected answer. Now how do we do this? So we're gonna say what is f of x first. F of x, it is equal to negative 2x squared minus 1. Negative 2x squared minus 1. Then what I want to find it is f of x plus h, which gives me how much? It is negative 2. When I see x, I substitute x plus h squared minus 1. Now, I always tell my student this, that when you see, if your f of x, your original function has x squared, it means now when you start to substitute them, when you start to substitute on your equation, those x squared should be gone, meaning the one with the highest degree power should be gone. Even if we had minus 4x cubed, it means the one with the highest degree power, this one should vanish. Okay, yes, you'll see what I mean. What is when you simplify this, you get negative 2x squared minus 2xh minus 2h squared minus 1. So I'm gonna say find f of x plus h minus f of x. How much is that? It is negative 2x squared minus 2xh minus 2h squared minus 1 minus, what is this one? I'll remove this pen. It is negative 2x squared minus 1. So I want you to see here, Negative 2x squared plus 2x squared, it cancels off, right? Negative 1 plus 1 cancels off, right? You all agree with me? Yes, look, it is gone. What I'm left with now, it is what? I'm left with negative 2xh minus 2h squared. Remember what I said? I said something x squared should be removed. Do we have any x squared here? No. So it means everything it is correct. Then now I'm in a position of saying what is my f prime of x according to the definition? It is limit as x approaches 0 of what? Of x of f of x plus h minus f of x, all divided by what? All divided by h. You're gonna continue with this limit until the final step where you substitute. But I know what is f of x plus h minus f of x. It is this one, this part I just calculated here. Okay, so this makes your life easier rather than coming to substitute here and make mistakes. Then I'm gonna take out the highest common factor, limit as h approaches 0. Highest common factor, just take h as a highest common factor. Why? Because we want to eliminate this h at the denominator. Okay, I have negative 2x minus 2h divided by how much? Divided by h. Therefore, you allow me to say limit as h approaches 0, it is what? It is negative 2x minus 2h. Then I can substitute. Now h as what? Limit as h approaches 0. University is going to be the end of me. Limit as h approaches 0. As h approaches 0. Not x, sorry. Before I recorded the video, I was busy with calculus. So hence I'm stuck with those. So yes, I'm going to substitute h as 0. So it's going to be, when I substitute h as 0, it's going to be negative 2x. Realize when I substitute, I do not say limit. Okay. Now remember I said my expected answer should be how much? What the? I said my expected answer should be how much? Negative 4x. How much do I get? I get negative 2x. So it means somehow I did a mistake. I come back here. Probably somewhere here. Let me see. I want to see negative 2. This is going to be, or here. The value here should be negative 4x-ish. Negative 4x-ish. You see the importance of seeing what the answer is before you come and substitute here. You realize that if there is a mistake, you can fix it quickly. 4 here, then here it's gonna be what? It's gonna be 4. Therefore, when I substitute, it's gonna be negative 4x. You see now the benefit of checking my answer using rules, differentiation rules, before using the first principle first. All right. Now let's go to differentiation rules. Differentiation what? Differentiation rules. Now we have a couple of differentiation rules that say to us. Let me start by going through those rules. The first one is saying whatever that you are differentiating with respect to should not be inside a radical, should not be inside a bracket, like something like this. So we have to remove this by saying x to the power of 1 divided by 2. If we had a cube root of x, it was going to be x to the power of 1/3. So whatever that you are differentiating with respect to should not be inside a radical. Another rule is that whatever that you are differentiating with respect to should not be in the denominator. So you take it to the top part, right, to the numerator. Or if you have this, What you only take, it is what you are differentiating with respect to. It is the one that you're gonna take to the top, which becomes x to the power of -3, or you can just say 1 multiplied by x to the power of -3, which is basically x to the power of -3. These two, you just leave it as it is. Another part that you know, it is a plus b divided by c, it is equal to a divided by c plus b divided by c. I believe you are following. Now we are in a position of answering. Determine f prime x, the derivative of f, if it is given that f of x, it is equal to -2x cubed plus 3x cubed. This is very straightforward. F prime x of this one is going to be -6x squared plus 6x. Why? I'm going to say 3 multiplied by -2, it is -6. Then I subtract 1 here, it is 2. Then I'm going to repeat the same. 2 multiplied by 3 here, it is 6. Then 2 minus 1, it is 1. So this is your 2 marks. That is your 2 marks. Okay. Now derive y with respect to x. This is how we call this. Derive y with respect to x. So is your y in a position of being differentiated? No. Why? Because whatever that you are differentiating with respect to, which is x, it is at the denominator and it is inside a square root. So we have to remove that. How? So the first thing that I'm gonna say is that allow me to do this here. I'm gonna fix this y first before differentiating. When you differentiate once at all. So as long as you are fixing something, you do not differentiate the other. Okay. So it's gonna be what? 1 divided by 4. Actually, this is a, remember, square root of 4x. It is the same as saying square root of 4 multiplied by square root of x, which is 2 square root of x. So this is the same as saying this is 2 square root of x. But now, what is square root of x? Square root of x, we want to remove this as a square root. So we're going to say it is x to the power of half. X to the power of half. Okay. We still have our unique one there. But now, I also want this, whatever that I'm differentiating with respect to be at the numerator, not at the denominator. So I say it becomes 2x plus what? X to the power of negative half divided by 2, because this 1 multiplied by that, it is that. All right. Then now I'm in a position of differentiating. But so that you cannot confuse yourself, do this 1, then put this here. You'll see why I'm saying that. Now, everything, it is in standard form. Now I can do what? Derive y with respect to x. You have to write this. This is very important. You have to write this. What is dy dx? Dy dx, it is, you differentiate this, you get 2 plus. Why? Because it is 1 multiplied by 2, it is 2. Then 1 minus 1, it is 0. Then x to the power of 0, it is 1. Then 2 multiplied by 1, it is 2. I am Eminem, I am repeat. All right. Then this negative half multiplied by half. Do not say it is 1. It is minus 1 divided by 4x to the power. Then you're going to subtract 1 here. When you subtract 1 there, it is -3 divided by -3 divided by 2. Let me just confirm. Oh, I'm lying. Mpo. Negative negative half. Actually, what's happening at? Yes, -3 divided by 2. I was correct. So this is your final step. So they're gonna mark this final answer, and then what? You removing this square root as well as moving this in the numerator. All right. Now, the interesting part of the questions. Now they say to us, The graph of y is equal to f of x has a minimum turning point at 1 and -3. Determine the values of x for which f is concave up, concave down. So now they say this graph here of the derivative has a minimum turning point. Remember, if I have f prime, f prime prime, normally I have this. Normally I have this as my function. Then I have this as my second derivative. Then I have this as my straight line. Or I have this, probably you're repeating the same thing. I have this, I have this, I have this. So now I'm told that whatever that I have, it is f prime x. So it is between this and this. All right, this is the strategy that I'm giving you. It is between this and this. Oh, now how do I know from this one, the graph of the derivative, it is this one? You check the last shape. The last shape, it is what? It is this one. So it is happy. How do I know this is straight line? You check the last part of this, which is like this, increasing. So yes. Similarly, here the last shape, it is decreasing. So your first derivative will be decreasing, like this said. Then for this straight line, you see, it's gonna be like that. It is very nice. Now, I'm told that, oh, another thing is that the x-coordinate of the turning point become the x-intercept. The x-coordinate of your turning point become the x-intercept of your parabola. All right. Then the point of inflection become your turning point. Then your turning point of your parabola becomes your x-intercept for the straight line. I repeat, the x coordinate of the turning points become your x-intercept of the parabola there. Then the point of inflection become the what? The point of turning point. Then yeah, all of that. Let me remove this and explain what I was trying to explain actually. Let me try to erase this mess now that I've caused. Alright, here I said I have a function like this. Alright, now I'm told that the derivative has a minimum turning point. Minimum turning point. Where's my minimum turning point? This is the maximum, right? Then this is the minimum. So it means I'm looking at this graph. So it has a turning point there at 1 and -3. So now I know when I repeat, when I derive my f, I get my parabola. But now the x coordinate of the turning point of my cubic function become my x-intercept. If this is the turning point, they become my what? My x-intercept. Intercept. Then the point of inflection here, become my what? Becomes my turning point when I derive this. So now in reverse, if this is my turning point on graph of the inverse, if this is my turning point on the graph of inverse, what is it going to be on the graph of f? Is going to be my what? My point of inflection. So it means here, this coordinate, the x coordinate only. So it means here the x coordinate, it is how much? It is 1. So this is what I needed to explain so that you can see. So the x coordinate there, it is what? It is 1. Now, if that coordinate it is 1, we can answer the question. Determine the values of x for which f it is concave down. Concave down, it is like this. So it is concave down where? From x going to the left. So you're gonna say x should be less than 1. This is where your graph should be concave concave down. The values of x where it should be concave, concave down. I'm done. I'm done. I'm done. So yes, thank you. That's all for question 7. Let's meet on question 8.